Hello, and welcome to Linear Functions. My name's Tuesday Johnson. Here are the applications. So if it costs Meta $1,230 to manufacture 8 VR headsets per hour and $2,430 to manufacture 16 per hour at a certain factory, write the corresponding linear cost function. Look who didn't write a period at the end of that sentence. Oh my goodness. So let's start by extracting data. We'll put the units, the dollar sign with the 1,238 headsets. So we'll keep our units together. We'll kind of keep these numbers 1230 and 8 gathered together, 2430 and 16 gathered together. I'm not sure what we're going to do with them yet, but those seem like to be the relevant aspects. So then we'll organize appropriately for our X and Y, and really think of this as input, output more than anything. And if we look, we have a linear cost function, a cost function. We've seen those before. That's C of X. So cost is the Y value. It's the output. The input will be the number of headsets. Our points are 8, 1230, and 16, 2430. So we want to find the slope. We'll use our slope formula, Y2, 2430, minus 1230. All divided by, in the same order, 16 minus 8. 2,430 minus 1,230 is 1,200. 16 minus 8 is 8. And when we do the division, we'll end up with 150. What does this mean? Think about it. In the numerator, we have costs. This denominator is headsets. This is cost per headset. All right, let's keep that in mind. Let's find our B value. In our equation y equals mx plus b, I could use my slope and one other point. And which point am I going to use? I'm going to use the smaller one. It seems easier. So y is 1230 equals m, my slope is 150, x, the x value of my quote easy point is 8, plus b. If I want to get b by itself, I'll subtract 150 times 8 from both sides. So I have b equals 1,230 minus 150 times 8. So that happens to be 1,200. We did it up here, kind of in a reverse, in a familiar operation. So 1,230 minus 1,200 leaves us with 30, and we can write the function as c of x equals 150x plus 30. All right, now from the previous example, we found a cost for virtual reality headsets, and we said Meta there. I know this is Xbox, don't worry. I just wanted more than one type. We found the cost at 150x plus 30. What's the cost to manufacture each additional VR headset? Use the cost function to estimate the cost of manufacturing 40 VR headsets in an hour. Well, the cost for each additional virtual reality, what did we say? We said that slope had units of cost per headset. That's exactly what our slope is, right? Cost to manufacture each additional headset is $150. The slope. As headsets increase by 1, the cost increases by 150. If I want to find the cost of 40 headsets, I'm going to start with a skeleton. The cost of something is 150 multiplied by that thing plus 30. So let's flesh it out by putting in the 40 headsets that we need here. So I'll put 40 in my parentheses. Do the multiplication. 150 times 40 is 6,000. Add 30, I'll get 6,030. But don't forget, this problem started with words. We should be able to end it with words because we need to be able to interpret our answer. What does this 6,030 actually mean? Well, it's a cost. It's the cost of what? The cost of 40 virtual reality headsets to be manufactured in 1 hour at this factory would be $6,030. Right? Make sure you understand what your inputs and outputs are saying, and a sentence helps you do that. All right, in the Fahrenheit temperature scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. And that's funny because I said the word Fahrenheit 3 times in one sentence. In the Celsius scale, the water freezes at 0 degrees and boils at 100. Given that the Fahrenheit temperature F and the Celsius temperature C are related by a linear equation, find F in terms of C. Well, it's linear. And for a linear equation, we know we have a series of steps. Let's start by extracting the data. We know that water freezes at 32 Fahrenheit and 0 Celsius. We know water boils at 212 degrees Fahrenheit and 100 Celsius. So maybe we'll keep those together. Now we want to organize appropriately for X and Y. And this is where we return to our question. Find F in terms of C. F in terms of C tells us that Celsius is the input. So in my pairs, I'll put the 0 Celsius and 32 Fahrenheit, 100 Celsius, 212 Fahrenheit. This format, F in terms of C, will tell us the order for our points so that we can find our slope, which is 9/5. We can find our B value. Hey, look at that. Don't forget to work smart so you don't have to work so hard. 0, 32, that is a y-intercept. When the x value is 0, the y value is the value of b. So our b is 32, and we could put this together. F evaluated at C is 9/5 of C plus 32. The formula, if you're given a Celsius, how to determine the Fahrenheit temperature. So let's do it again. Fahrenheit, water freezes at 312 and boils at 212. In Celsius, water freezes at 0 and boils at 100. They're related by a linear equation. This time we want to find C in terms of F. So we start by extracting the data, and it looks very similar to what we had on the last one, right? The freezing temperatures, the boiling temperatures. I kept the F and the C with them, so I knew my units as I go into organizing appropriately for X and Y. C in terms of F. C evaluated at F tells me that F is the input. So now I'll organize my points as 32, 0 and 212, 100. A lot of times your points could be organized either way. Look at the statement of the question / activity that you're supposed to do, and that'll help you get them set up correctly. We could find the slope. All we did is switches the x and y's. So our fraction just flipped over, a little reciprocal there. Slope of 5/9. We could find our b value. In our formula, y equals mx plus b, I'm using the easy point. Y is 0, m is 5/9, x is 32. To find b, we will subtract 5/9 of 32 from both sides, and that's some decimal. And decimals don't tell you the whole story. They're a little bit of liars. So we're going to keep this in fraction form. That's a negative 160/9. If it doesn't make a nice decimal that ends and you have to decide how to round it, don't round it. Turn it into a fraction. And we can put this together into the equation. It's actually a function, right? The function C of F equals 5/9 F minus 160. So there's an equation that converts from Fahrenheit to Celsius and Celsius to Fahrenheit. We can use these two equations to go back and forth with some examples. On our first example, 14 degrees Fahrenheit is equal to what temperature Celsius? Well, we know we have an F value of 14. If we have an F value of 14, we'll use our C equation because F is the input. So 5/9 times 14 minus 160/9. When I multiply, that's the same as 14 over 1. So I end up with 5 times 14, which is 70, over 9 times 1, which is 9. 70/9 minus 160/9 is a negative 90/9, which simplifies to a negative 10 degrees Celsius. Now in our second number one, there we go. We want to know if we have 30 degrees Celsius, what is that in a Fahrenheit temperature? Am I cold or am I hot? Well, since we have an input of 30 degrees, in Celsius, we'll use our F equation because we have an input of Celsius. We could use this one and solve, but that just seems harder. Why not use the one that is an input? So we'll have 9/5 times 30 plus 32. 9/5 times 30 is 54. Plus 32 is 86. Talking Miami weather here. It's 86 all the time. Our third number one there. Now, my favorite example, I was very fortunate to learn this while the temperature was at negative 40 degrees Fahrenheit, and I wasn't cold, as it turns out. Here we go. What's negative 40 degrees Fahrenheit? Well, if we put negative 40 in for our F in the C equation, 5/9 times a negative 40 minus 160 over 9. Again, if I am multiplying by a fraction, sometimes it's easier to write it in fraction form. So 5 times a negative 40 is a negative 200. 9 times 1 is 9 in the denominator. Still minus our 160 over 9. Negative 200 minus 160 is negative 360. Divided by 9 is negative 40. The temperature, negative 40 degrees, you don't have to use units. As long as it's Fahrenheit and Celsius. If you're talking Kelvin, you got other things. Radium Hot Springs in British Columbia, Canada is where I learned that fact. And I love it, as long as I'm in the hot springs. Thanks for watching. These are the applications of linear functions. Hit subscribe.